So for today, it's about writing equations. See, in the past, we would just say, here's your equation, solve it. But today, we start the process of teaching you how to take word problems and make them into equations like this. All right. So for right now, I just want to ask, is this one set up really nice to like cancel out as you like add things straight down? There's the equal sign isn't even in the right spot. No, this is not set up well for elimination. Is it set up well to graph? Well, this one would be easy to graph because it's solved for y, but this one would not. You'd have to do a bunch of work to solve it for y. And you'd need graph paper, so let's not do that one. So if we're not going to eliminate because it didn't line up right, and we're not going to graph because this one's a pain in the butt to graph, the second one, then what's left? Yes, Jack. Put it in, which, yes, it means substitute. That's substitution. There we go. This x plus 3 is going to go in to the other equation, but where? It says y equals x plus 3. So this goes into where y was, and instead of y, you put that. Now, this is really messy, but would you please copy this equation down again, except instead of y, you put x plus 3 in a parenthesis. If nothing else, copy this. And what do we put here? Never mind, you know?
X plus 3.
X plus 3. Do you get this as an equation? It's got only one variable. All you got to do is distribute. Add some like terms and solve the two-step equation. Go ahead, try this one. See if you can solve it. I'm pretty sure it works out to a nice whole number. Sorry, can you show me what you've done with it? Awesome, thank you. Two times the x, 2x. 2 times the 3, 6. Plus 3x equals 11. What are the two like terms here? 2x and 3x. What do they make? 5x. And then I'm just copying. Plus 6 equals 11. What's next? Yep, nice. 5x equals 5. Ooh, divide by 5, divide by 5. X equals 1. Raise your hand if you had x equals 1. Sweet. Okay, is that actually the final answer though? No. You gotta take a minute and go stick x equals 1 and do that. Go find one of the OGs, or in this case, original equations, OE equations. The 1 goes into, well, I'd probably put it in this one. If x equals 1, I go put 1 where the x was. Y equals 1 plus 3, y equals 4. 1 comma 4. That is solving a system of equations. And the biggest job for today is learning how to set up the equations, though. So let's take a minute. Just go off to the side. We're not going to go to the next slide. We're going to just go off to the side. All right. And now, if I said x is going to be a Snickers bar, it's how many Snickers bars I get at the gas station. And y is going to be hot dogs. What if you pull into the gas station and you've been complaining to Dad, like, gas station for lunch, Dad? That's pretty bad. And he's like, tell you what, get any 7 items that you want. And you could get all Snickers bars, or you could get like 3 Snickers bars and 4 hot dogs. Get any 7 items. And if we narrow it down to just these 2 things to keep our math problem easy, then x plus y could equal 7. Do you get that that's an equation then? And I don't know if it's going to be I'll get 6 of these and 1 of those. That would make 7. Or I could get 2 of these and 5 of those. That would make 7. So that equation represents all the different ways you could choose 7 items. All right. Now let's say that you bought 2 Snickers bars, 2 X's, and you bought 3 hot dogs, and it cost you a total of $20. Do you get we have a system of 2 equations, and we could solve this and figure out how many hot dogs you got and how many Snickers bars you got? Now, pause for a minute though. Do you get how I wrote that equation? I had 2 of the Snickers bars and 3 of the hot dogs, and it cost me $20. You see how that's an equation? All right. So I know you'd be able to solve this. We could do the whole like draw the line. Do these cancel nicely? No. So then you'd have to multiply the top by -2. Do you get what I'm doing here? Don't do it. Just look for a second. Do you get why I did that? So that these 2 would cancel each other out? Does that make sense to you? That's called elimination. All right. But could you have written the equation? That's really the question. All right, so let's do one more like this. It'll be with hot dogs again, or hot dogs and Snicker bars, just to keep your life simple. This time, Dad doesn't say 7 items. This time he says 10 items. Any 10 items. Go ahead, make that equation for that. You can get any 10. Do you have x plus y equals 10? Good. Now, I just realized that I made the last problem a little too easy, and therefore it wasn't quite right. But I'm going to make this one more realistic. So imagine that we know the price of Snickers bars, and they are $1.05. I hope that sounds like a reasonable price. Okay, and let's say the hot dogs are $1.45. And let's say that we spent a total spent at the store was $14.50. We already got one of our equations. Can you write the other one? Now, hint. The other equation must involve $1.05, $1.45, and $14.50. Because I gave you that info and we got to put it somewhere. Here's a common mistake answer. X plus y is $14.50. No. X plus y was 10. X plus y can't be something else. think once you see this a couple times, it won't be that bad. It was $1.50 for each X. I could put a 0 there. Plus, it was $1.45 for each Y, and it totaled up to $14.50. Now, if anybody's good at what I would consider like street smarts here, you can probably tell me how many of what I bought. You could probably look at it and just go, oh, I can tell you probably bought this. Yes. What do you think I bought?
It's supposed to be $1.05.
Oh, thank you. 1.05. Sorry. He's right. Right here. I reversed those two numbers in my head. That's called transposing. 1.05 X. Okay. And since it's $14.50 and it's $1.45 for each hot dog, did anybody notice that that was probably it? I probably just bought 10 hot dogs. You know, I got 10 items, right? And if they're $1.45 and you do it times 10, it's $14.50. I probably bought 10 hot dogs. And that's true, but you wouldn't have had to solve it that way. So do you get that this price went with the X? So there it is, 1.05X. This price went with the hot dogs, and that's right here. 1.45 was the Y's. And it totaled up to $14.50. All right, here's another one that you can relate to. Do you get that the play that we have, I think we have the Addams Family going on right now at our school. Do you get they charge different prices for adults and students? If your parents want to come, it's probably more expensive for the kids. The students here, it's cheaper tickets. All right, so let's make X be the adult tickets and Y be the student tickets. Have you noticed that every single time I have defined what X and Y are first? That's really important. You got to figure out what's going to be X and what's going to be Y. And you could make them different letters like M for monkeys and S for, sloths. Okay. But I usually use X and Y. So we're talking about the Addams Family. The cost for these tickets, well, for the adult tickets, I'm just going to put it in parentheses underneath. Let's say that it is $20 for an adult ticket. I know that seems like a lot, but the plays are really good here, so maybe it's accurate. Student tickets, let's say that it's $5. It's probably more, but let's say that it's that. So far, do I have any equations? No, I don't. But I have a fact that X is the adult tickets, and they're $20, and Y will be the student tickets, and they're $5. All right. Now, let's say I said the theater holds 500 people. You can write an equation for that. I'm going to pause for a second. Just don't overthink this. All I said is that the total number of people, which is adults and students, is 500. There'll be another equation involving money in a second, but this one is just it holds 500 people. Do you get that means X plus Y is 500? Who had that already on your paper? Okay, good. That's all there is to that. Why isn't it 20 for each? Like that's when you get money involved. That'll be the other equation. It'll be 20X plus 5Y. You know what I mean? That's when you do money. I didn't say it was $500. I said it was 500 people. Okay, now let's say that they took in $4,000 total. That's the other equation. $4,000 was brought in one night. We should know that means equals $4,000. And then, pro tip, it's usually X and Y together, but it can't just be X and Y. We already have an equation for X plus Y. So, did you realize it was 20X plus 5Y? Raise your hand if you had that one right. Cool, you're catching on. This is it. That's writing the equations. And then you just have to solve them. So if you want the extra 5%, these are the hard problems, you'd have to now be able to take the equation that you took all that time to write and solve it. So let's take a second and do it. The first thing I ask myself is, would this eliminate? Yeah, actually it would if I did something to one of the rows. Do you think I should multiply the top by something? Yeah, what? Say it if you know. 20 is close, but not exactly right. Negative 20 is correct. And I do that to all of them. I'm timesing by negative 20 all the way across the top. Why am I doing that? So these will cancel. Now see if you can finish it. Now I totally get calculators are allowed in this class. Pretty much every test. When you put these together, negative 20 plus 5, you'd add 15y. And here, I'll be your calculator. 5 times 2 is a 10, but then you have to add the 3 zeros that are already in the problem. So that's 10,000. But it's negative. So that's negative 10,000. When you put these two together, that makes negative 6,000. Now, this one's not going to work out nice. But that's generally the idea of how you set these up and how you solve them. Actually, it's humanly possible this could work out nice. Negative 20 plus the 5 is negative 15. I don't know, maybe this does work out. Let me just check it. Negative 6,000 divided by negative 15. $40. It's not that bad. Why is 40? Now you got to think about context. Is that like the number of yaks? I think 6,000 divided by 15 is 40. I'm double. Oh, I had 600 divided by 15. So then is it 400? Do you guys get 400? Okay. 6,000 divided by 15. Try it again if you didn't get that. 6,000 divided by 15. 400. There we go. Now think about the context. Is this about like how many yellow crayons there were? No. What was y again? We'll look back at the top. The first thing we did was define it. Y was students. Yes? Yep, so see that negative right there? You're right. And I just divided both sides by negative 15, and so I had negative 6,000 divided by negative 15, and that got me this 400 right here. Pretty sure I got this right. And you're right that I missed that the first time, but you didn't notice I did sneak that in there. So, okay. So y is 400, and I look back here, and 400 students. Well, if y is 400, we must add 400 students. And then if there was a total of 500 people, there must have been 100 adults. See how that works? All right. I know that's super intense. I know that some of you, that's a bridge too far. You're not going to get that kind. That's okay. I know some of you can. I'm going to give you one last one. Let's see if you can get it. Define what x and y are. I'm going to tell you up front. A lot of times we talk about buying two different things because this is a real world scenario. You buy a couple things at a store. Okay. So this time it's going to be apples. And hey, how are you doing? Welcome. It's going to be x is apples and y is bananas. Somebody give me a real life price for an apple. $3.50. Man, you got expensive apples, but that must be the Harrelson apples. They're good. And how about the bananas? Just give me a number. Doesn't matter. They're fairly cheap, aren't they?
$1.49.
Okay. Then my question is, can you set up this scenario? You're going to buy 5 items. There's an equation for that. And You're gonna spend $17.50. Can you write an equation for those two things? I want to pause while you give that a shot. Here's that solution to that last one. And now we are on to just doing the Schoology quiz number 1. Would you please read it again?
X minus 3y
Equals 3. And then the other equation?
y equals -5x minus 17.
Now, does that look all perfectly set up for doing the eliminate method? No, they don't line up at all. So I would not eliminate. Could you break out graph paper and do this with graphing? Yes, but you'd have to solve that first one for y, and that would be a pain. You'd have to subtract x on both sides and then divide by -3, and it would be gross. So, instead, let's do substitution. Whenever they tell you, like, y equals this, it is solved for y, and that's just begging to be stuck in where y was. Now, there's no way you're doing this in your head. So get out some virtual scratch paper or regular paper and write this out. X minus 3 parentheses. This is where you put all of this. It goes right where the y used to be. -5x minus 17. And then I'm just copying this equation down here. And the equals 3 goes at the end. If you can solve that, you'll have the x. A little bit of distributing. Combine like terms. And then I think at the end, does your answer want it to be in a point? Does it say on number 1? Thank you. Wants it as a point. So if you figure out that x equals like 2 or whatever, then you got to go stick it back in one of the other equations to get the y. All right, and that's all I got for you for today.